Hey guys, how you doing? I'm gonna do a video on my the last video that I did for the electrical episode, where I was showing the taillights on the back of the Bug. I had a couple people ask me questions in there. I talked about using diodes in order to drop down the voltage a little bit to control the brightness on some of the lights, and I think I confused a couple of people with that. So I want to explain it a little bit more so that if you guys are possibly trying to do something like this on your Bug, you won't have any problems. I'm explaining this the best that I can. Bear in mind, I know what you need to do. I don't 100% understand exactly why, but I'm going to explain it to you guys as well as I can. The LED in itself doesn't really have a lot of resistance. So when you send voltage through it, it will actually allow more current than it needs. And it can be, number one, it'll make your circuit so that it draws a lot of current. And number two, it'll heat up the diode. So what I've got is, I've got this little lithium battery. I'm going off just one cell, so it's about 3.5 volts. I'm coming into my breadboard. I'm looping around. I'm going through this one LED. And then I'm coming out and I'm going into my voltmeter, which I have set up to read milliamps, so that I can see how much current is going through the LED. So I'm going to hook power up. Now you can see the LED is lit up, and we're burning about 103, 104 milliamps. Now that's without a resistor. Remember that, 102, 103 milliamps. Now I'm going to put a 220 ohm resistor in front of the LED. So now I'm going from the battery, through the resistor, through the LED, and through my voltmeter, which is going to give me amps. So I hook up the battery, LED lights up. Now if you remember before, I think we were at 102, 103 milliamps. Now we are at 7.9. 7.9. So we dropped close to 100 milliamps. All right, so that's a significant reduction in draw across that diode. So that's why you need the resistor. In a sense, it just limits how much current can go through those LEDs. They're still going to light up, but they won't draw as much power. That's as well as I can explain it. Now, that has nothing to do with what I was talking about for the wiring on the Baja. What I was talking about on the wiring for the Baja is these LEDs in here, they're on this printed circuit board, and you know, there's 3 wires here. There's a ground, there's a tail light, and there's a brake light. But they're doing it all out of the same LEDs. The way they're doing that is they set up the brightness of these LEDs for the brake light, and then in order to give you tail lights, they step the voltage down by using diodes. So what I had found with these is I wanted to use them for brake lights and for tail lights, but there's that intensity and that intensity. All right, so this is their tail light, and this is their brake light. As you can see, there's not much difference, and that would not be safe. Like, I could not use that as my primary brake lights. So first of all, I just use these as supplemental brake lights, but in order to make it more distinguishable, tail light, brake light, tail light, brake light. In order to make it more distinguishable, what I decided to do is add my own diodes to the tail light so that I could dim it down and make it darker, so that when I turned on the brake lights, it would be more obvious that I had put the brakes on. And in order to do that, I stacked up some diodes in series. So I'm going to set that up on the breadboard just like I wired it, and then we can measure the voltage as it goes through there, and I'll show you how if you stack them up in series, you can reduce your voltage. And what I ended up doing is I put 4 diodes in series to lower the voltage, but I'm going to show you on the breadboard how to do this. Okay, so now got the battery here. If you can see, I've got 1, 2, 3, 4, 5 diodes in series. So the battery, the voltage for this battery is coming in here. It's got to go through the diodes. I've got a resistor in there just for a load, and then it goes back to the battery. So I've got my voltmeter here. Let's see if I can set this up so that you guys can see it all. So I've got this probe alligator clipped onto the end here. So if I go to the beginning of the circuit, I've got my 3.2 volts. And then as I come in, we'll be dropping off diodes. So we've got 3.2, 2.5, 1.9, 1.2, and finally 0.6. So this 0.6 actually represents the voltage drop through one diode, because right now we're just measuring the voltage drop across this one. So that's our 0.6 drop. Add another one in there, we're at 0.12. Add the third, we're at 1.9, 2.5, all the way up to 3.2. So as you see, as you add diodes in there, it takes your voltage further and further and further down. So when I had wired up these lights for the brake lights on the back of mine, on the circuit that I was going to use just as the tail light, I added 4 diodes in there, and we saw that one diode is about 0.6 volts. So if I had 4 in there, I was dropping about 2.5 volts off of the light, which made it so that the tail light, when it lit up, was significantly darker, and then when you turned on the brake light, it actually looked like a brake light because it was brighter. So that's it, guys. I just wanted to show you how the resistors are just to put a load on the LEDs so that they don't flow too much current through them. That's what the resistors are for. The diodes, which is what I was talking about, are there just to reduce the voltage so that I could lower the brightness of the LED. So I hope that helps, guys. Hope you learned something, and I hope to see you on the next video. Take care.